All right, everybody, as promised in my previous video, I'm going to be testing out eco-worthy solar chargers. They're 120 watt solar chargers. One was faulty. It only gave about 70-80 watts. The other one was a replacement. You can see that this one is a little bit of worse wear than this one. And the replacement was fully 120 watt when we tested the voltage and of course the short circuit current. And we're going to do that today. It's a nice sunny day. It is noon. Actually, no, it's not. It's about 1 p.m. so perfect timing. With DST, that makes it ideal conditions for testing this. We should get full power from both panels and we'll see how they do. All right, both panels are set up. As you can see, this one has got the straps. This is the original one. This one doesn't have the straps, but they sent me one without the straps when they did the replacement itself. And I got my voltmeter first. So let me just set up for the voltmeter. And we're going to be testing the first panel, the original panel first for voltage. And of course, I need to set it up for voltage. There we go, 22.8 volts. Now the second one, this is the negative, this is the positive, 23.1 volts, so about the same. So now it's time to set it up for the amperage, open circuit amperage. We are going to test the old panel first. It is doing about 4 amps. So that still makes it a 80 watt panel. And now the second one, the replacement, 6 amps, almost 6 amps at 23 volts. That actually makes it a little bit better than last year. So it's a nice sunny day and we should get nice results out of it. What I'm going to do is I'm going to plug it to my solar charger, and once I plug it to my solar charger, I will get my phone app out and I will show everybody the performance of the panels. My battery connected to these panels now. All right. $82 watts. That is disappointing. That's probably a bad MPPT because it should be pulling more than 82 watts. That is poor performance from the MPPT. That's something I would expect from a PWM. That is definitely not good performance. Okay, let's try the old battery. Last year we got about 60 watts out of the old battery, the old panel. Sorry, not the old battery. The old panel. So let's pull this cable in. All right, so now I've plugged the old panel onto it. Now it's gonna say, okay, let's see what it has. It says, okay, I do 21 volts, 3.1 amps, 54.5 watts. Yeah, about 60 watts. Maybe maximum once it settles down. So yeah, as you can see, even MPPT chargers are not all MPPT chargers. So what I need to figure out now is a good MPPT charger that will actually deliver what it promises. However, all I can say about the panels is that they have survived winter well. I don't see any degradation from last year. I can see that the panels are basically operating nominal. The one that was, of course, 120 watt is still 120 watt. It gave me a 6 amp short circuit amperage, and it also showed that it's got 23 volts open circuit, which is what, 3 times 6, that's 138 theoretical watts out of that panel. And yeah, my controller is only pulling about 85 from it. Yeah, I'm not super happy I'm really not super happy with that. So what I'm gonna do is I'm gonna switch back to my PWM charger, just the one that comes with the solar panels themselves, and see if that gives me about the same results. All right, let's do one more thing. I just thought of it. Let's put these two panels in parallel. So I'm gonna use this Y thingy here, and I'm gonna plug them in parallel. I have no idea whether you can see anything or not. All right, so positive to two positives, negative to two negatives, and one positive to one positive, the other one here, and then the two positives going in here. Okay, so let's see the results. Now that we have it wired this way, we should have a much better charging pace from these two platforms, from these two batteries. And now it's saying it's charging 19 volts, 5 amps, 94 watts. So not the 130 that I was expecting. Oh, clouds. Clouds. All right. Yeah, now that we got clouds, we can't really get a good result from it, can we? 7.8 amps, 135 watts from both panels, 136 watts from both panels. Can we beat that? 137. Yeah, so it is trying to adjust. So it is doing its MPPT magic. It's trying to adjust and figure out what the best combination is, right, of voltage versus amperage. But it's giving my battery 13.5 volts, 9.3 amps. So yeah, it's charging pretty good. Now, considering that this is a 280 amp hour battery, this will take 28 hours of charging on both of these panels at this rate to charge up. So the lesson learned here is, yeah, definitely what I need to do is I need to get a better charge controller to get a better result, don't I? I think so. All right, we're at 139 watts now, and another cloud, and it breaks it. It breaks it. Okay, one more thing we can try is actually putting these things in series, because this charge controller can actually handle that, whereas the other charge controller won't be able to handle that, the PWM. So don't do that with your PWM. If you're using just the PWM, I do not recommend doing what I'm doing right now. But having them in series actually means that you're going to be able to start your day faster, because it's going to charge with a lesser voltage. So what I do is I plug one of these here, I plug one of the other ones into the other one, right? And now I plug this one here, and now they're wired series. So it goes to that panel and then back to this panel. So it goes to this panel and then back to this panel and then over to the controller itself. So now we should see, we should get a higher voltage. All right, so it's saying it's getting 24 volts now for charging, 32 volts for charging, 1 amp. And let's get some sun, please. Come on, clouds, give us some sun. Give us some sun. See, this system is a MPPT controller, because it is able to convert the 40 volts into a 30 volt input, right? There we go. We're doing 37.6 volts, 3 amps. Yeah, so 64 watts. So what is happening here, I think, because these two panels are mismatched, I'm going to be capped at the amperage of the smaller one, if I'm not mistaken correctly. So about 4 amps. We'll see what happens. 127.5 watts, 33 volts, 3.8 amps. This is about the open circuit voltage of the old panel, of the original panel. So if these panels were matched better, I could put them in series, and then they would start charging much earlier in the morning. So let's say, you know, I would want to start charging trickle charging the batteries a little bit very early in the morning, and I'd have them pointed at in sort of the easterly direction. They would definitely go above the required charging voltage, right? So if each panel produces like, you know, 7-8 volts, that gives you enough to start charging your battery at the 12 volt, 13.5 or whatever voltage is required to start charging that battery. So yeah, that's another option. However, let's see, is this making any difference? Is it making any difference? Let's see. Now the sun is out, it's doing much better. So it's now, voltage is raised up, amperage is up, right? So technically the potential here is about 42 volts is the potential maximum, theoretical maximum, and 42 volts at 4 amps. So maybe like 160 watts at 4 amps is definitely a possibility here. 135 watts, 131.5 watts. Yeah, so this is a really good setup if you're just into wattage, is actually wiring these in series, because you have way less losses, right? Because you have way less amperage, so you can have a longer cable at higher voltage. So if I was designing a system from scratch for, let's say, an off-grid environment or something like that, I would definitely go for something like a 48 volt system. Yeah, this is working, and all I need is a better controller now. So that is it. I'm gonna say thank you very much for watching, and you should see some more solar fun with Marco in my next videos that are coming up. Thank you very much. Bye.